This is the upright Aleron trike. It is a tilting three-wheel tricycle with electric power assist. Note that this machine can stop a track stand. It also leans like a virtual bicycle. The loads are completely balanced at all times except when the machine is locked at low speeds. Note the dynamic behavior of this machine: the speed, the narrowness of the track. This means the machine has a small footprint and a small swept area. It can also carry additional loads. There's ample storage capacity in the front. Braking is superior. Cornering is superior due to the additional hardware installed in the front. The two wheels give additional roll stiffness and feed cornering forces directly into the frame. There are no cantilevered inputs. Note here the rider can back up the systems by directly manipulating his feet against the wheels. You can stand up like on a normal bike. This machine can also be a work bike or a commuter bike. You never have to put your feet down in the ice and snow. The extra stability that it has is a reserve stability, both in the leaning mode and in the lock mode. In the leaning mode, if one wheel slips, the other wheel could pick up a load. And in an emergency, if you need additional stability while moving in a straight line, you can momentarily engage the locking device until balance is re-established. On our more sophisticated designs, there's a device called a half lock, which engages automatically as in a pendulum fashion. If the machine falls at a higher rate than the rider does, such as in a skid, the machine engages in a locking condition, which unlocks when the machine regains balance. And the input comes from the rider's basic physical inertia and in the fact that he is holding on to the handlebar. In this view, this is a Delta version of the Aleron trike system. What we have manipulating the control of the lock or unlock conditions of the paired wheels is what we call a dual center state reversing clutch. That is, even when it is not engaged, it can be engaged to stop the roll in one direction or the other, and allows it to move in a direction that the rider desires to roll into. When the machine is locked in the lock mode, if it's lightly locked, the rider can slip it from the lock position. You can slip it either left or right and regain a full lock condition from that condition, which is the second part of the dual center state reversing clutch. So in other words, it can be slipped from a lock position, or it can be half locked from an open position. Note the speed of this machine. A more advanced design would be in a compact long wheelbase design in which the front wheel is moved forward and the rider can have his legs closer to the ground. It will be easy to control. And this may be a lower power input position, but it's good for an electric bike because the rider input is not all that important other than an assist. And his comfort and control at the lower pedal position is more important and would be a better design integration. The design for the control of the pairing of the rear two wheels is called what we call a split swing arm. It is controlled by two links underneath to a tie bar and a walking beam arrangement. It is underneath the machine and is similar to the way they lay out a pull suspension on some motorcycles. This machine is very fast, very low, and very narrow. It has excellent control. It has in itself an anti-skid characteristics due to the way the wheel movement works. The wheels actually scissor up and down vertically. In doing so, the wheels, the track actually is increasing as it leans, which causes a scrubbing effect, which actually softens the rate of roll of the machine. And it likes to, this feature causes it to snub rapid skid or choke rapid skid. In this view, the machine has been equipped with foot pedals, which permit the rider to push directly on the wheels. The wheels are now just an extension of his feet. As he pushes down, it pulls the wheel down and forces the machine to roll in one direction or the other. This is similar to the arrangement that they used in the Wheeler invented for the GM Green machine. We find that this is not a good strategy at high speed, so when you have your feet on these pedals, the pedals feed back the roll position of the machine, and this can be disconcerting to the driver using it continuously because it tends to imbalance the rider. The faster the machine is moving, the less there is a need to have direct control of or input into the tilt position. The only thing that is needed is anti-skid roll or sudden roll augmentation. Where it is useful to put your feet on the pedals is when you're coming to a stop. It gives a more natural feel.